Hi everybody, I am coming to you from the National Astronomy Meeting at the University of Warwick, where there's a lot of science talks going on. If you can hear that applause that's going on behind me, of people coming together, sharing their work, their research, the latest science. There's about 500 of us here, and you can imagine the atmosphere is ramping up as we're, about 20 minutes or so from the James Webb Space Telescope live stream for the image release of these 4 or 5 targets that they've announced. See, last night we were all at the bar and having dinner and chatting together about what the image was going to be that they released last night, that President Biden announced, that we had to wait that excruciatingly long hour with all that wait music for, when we all just wanted to go to bed here as well, because it was a really late night in the UK and in the rest of Europe as well. But the image that was released, this incredible image of this galaxy cluster, an incredible distance, was everything we hoped for, right? I mean, it was very similar to, say, a Hubble Deep Field, and I've been basically just like flipping back and forward all day from like Hubble to JWST and just being like, oh my god, like look at the improvement on that. It's incredible, like, to think of the improvement in resolution. So let's chat about that image before we chat about what they're going to release later on, because I thought about doing a live stream, but apparently it's a full-on hour live stream when they're going to release the images later, and it's going to be like one image every couple of minutes. So I'm going to record my live reactions and then edit them together dead quick and get it uploaded for you tonight, rather than doing like a live like this. And I figured we could just chat beforehand and share our excitement and all what's going to happen and stuff like that. So let's chat about this image first. It was the galaxy cluster. It was SMACS0723. It was the deep field image, essentially, that we were waiting for last night, and it's just amazing, isn't it? So first of all, everyone was asking, what's the difference? Okay, so this is a star in our own Milky Way galaxy in the foreground, essentially, and then everything else is in the background. You've then got this main sort of group of galaxies in the center that everyone got really excited about, especially because can you see this like fuzz around the galaxies? This is what's called intracluster light. I'm trying to remember if it was inter or intra. And essentially it's like gas in the cluster that's just slightly glowing, and essentially we can see that in this image because JWST is so sensitive. So that was incredible to see as well. So that's around about 4.5 billion light years away, I think that was what they said for this. But then can you see all of these, my mic is clicking with my necklace, I'm sorry, I'll move it. Thank you for those who just, sorry. It should be okay now, I didn't think about that. And then there's all of these little arcs as well that you can see that are slightly redder than the sort of stuff in the foreground. Those are galaxies that are way further than 4.5 billion light years away. They could be anything from 10 billion to 13 billion yet. We don't know until we get a spectra of these things where you take the light and split it, not just get an image, and you get that sort of graph of the light of each wavelength, and there's like an emission line you can use as a pinpoint to know how far the light has been redshifted. These are lensed, essentially, so the galaxy in the center, this big galaxy cluster here, is acting like a big gravitational lens. So it's essentially bending the light around it, like if you take a stemmed wine glass sort of in front of a light in the background, or a candle light, and it bends the light in the stemmed wine glass at the bottom, and that acts as a lens. This galaxy is doing the same thing. It's just gravity rather than like glass that's doing the bending, and it's magnifying the light from these distant galaxies so that we can detect it with James Webb, and also so that we can actually see it as well. And you can see that's why they're obviously so much redder as well, because this has been colored as in the sort of the light has been redshifted into the infrared and then shifted back to the color it would be. And so obviously we're not receiving for these very distant ones the same level amount of blue light, for example, as we are for the nearby ones. And so these ones appear ever so slightly redder. Obviously, the other thing we've been doing is essentially just zooming in on galaxies around this field and being like, oh my god, look at the detail here, and look at the detail over here. There's in the Slack channel of all of our collaborators at the minute, there's essentially like people screenshotting like, whoa, look at this one, or like look at this one as well. And essentially some of the things that we've spotted as well, people got really excited about, because they think there's some growing supermassive black holes in the middle of these distant galaxies, because there's a slight, you know how I talked about this interesting shape that you get from the star in one of my videos before, this sort of 8-pointed shape, and that's just an artifact of the shape and size of the telescope being a hexagon. It's called a diffraction pattern, or a PSF, a point spread function. Essentially, if you have a bright point of light, you're always going to get that pattern as light sort of moves through the telescope and bleeds. Well, essentially, you can also get that on some of the galaxies in this image as well. Like if you zoom into them right in the very center, you can just about see it. Only my iPad can quite zoom in far enough here, but in the middle of this one there's actually this slight X shape in the middle, that the bright point source in the center of the galaxy is also making that diffraction pattern. And so we think there's actually a growing supermassive black hole, essentially a quasar, in the middle of those galaxies, and you can pick them up that easily just by the fact that you can pick out the point spread function in the image as well. So I think the Galaxy Zoo team, if anyone's ever done Galaxy Zoo, where you classify the images online, they're planning on doing a project where you literally just go through this image and be like, what can you see? What can you see? So it was a massive taster of what's to come, I think. And I mean, I was so happy when I saw it last night as well. I was just absolutely amazed. And so, oh, hi, sorry, so much being, I am doing a YouTube live. Do you want to say hi? Say hi, everybody.
Hey, everyone.
Everyone who knows Chris in the Sky at Night.
Hello.
Yeah, we'll be chatting later, won't we?
Yeah,
so,
exactly.
Yeah. Behind the scenes.
What do you think of the Galaxy image?
It was amazing. I'm just explaining it now and saying all the stuff we've been chatting about in Galaxy Zoo with the AGN that you can see in the middle of the point sources and stuff like that.
Yeah, which show up in the infrared, right?
Yeah, which is so cool.
Cool.
It's so cool. Yeah.
See you later.
Okay, so as I was saying, so yeah, this is amazing. You can tell we're all very excited, and you got a little bit behind the scenes. Oh, everyone's saying hi, Chris. Everyone, but those in the UK will know who Chris is. He was also my PhD supervisor as well, for context. So yeah, this was a very exciting image, and we were all excited to see this. But to be honest, I mean, if you flip back towards the Hubble image, wrong way. There we go. If you flip back towards the Hubble image, you can see okay, yeah, it's a massive improvement in resolution and detail and imaging, everything like that. But it's also very similar. We've seen this kind of thing before, right? We've seen images similar to this. So that's why I think we're all really excited for the next 4 images that they're going to be releasing in the next hour or so from 3:30, because I think it's going to be stuff that we haven't seen before, to be honest. For example, okay, so the list that we've still got left to see from those 5 they released the other day, for those who saw my Twitter, for example, I've just seen something, too much coffee. No, I don't drink caffeine because it makes me feel weird and jittery. I'm just high on space right now. Anyway, that sounded so geeky. Okay, so the 4 things we've got left. One is the Carina Nebula. So this is one of the largest and brightest nebula that we have in the sky. It's a big star-forming region, lots and lots of stars forming in it. It's a big cloud of gas and dust. It's about 7,600 light years away. And essentially, when we see it with the Hubble Space Telescope, it's one of these amazing, colourful, beautiful images that we see. But the dust blocks a lot of the visible light at the shorter wavelengths, whereas infrared light with James Webb can actually go around that dust. So we're going to be able to sort of see through the dust in this nebula, which would be great. Hubble could sort of do that because it could go into the infrared. But this will be slightly longer wavelengths with, say, NIRCam, one of the instruments on JWST that's at those sort of shorter infrared wavelengths. But the thing I'm most excited for is MIRI, which is the longer infrared wavelengths, the kind of stuff, massively absorbed by the atmosphere with no chance of spotting it from the ground. We have to do this in space, and we've never had a space telescope at these wavelengths, and we've never seen what these things look like at these longer infrared wavelengths that MIRI talks about. If you saw my MIRI sneak peek video the other week, you'll know what I'm talking about. I think I'm most excited for it because not only do we don't actually see through the dust with MIRI at these longer wavelengths, we see emission from the dust itself. And so I think I'm most excited for the Carina Nebula image, just to see what that looks like. And also for those who saw my Twitter as well, my favorite space image, and those who saw my space meme review a couple of years back as well, there is a part of the Carina Nebula that looks like the universe is giving us the birdie. It's flipping us off, essentially. So I'm just going to be zooming in, trying to find that bit in the MIRI dust emission, essentially. And then the next thing that they're going to release is the Southern Ring Nebula. So this will be pretty similar, I think, to the Carina Nebula as well. Obviously, it's just a different shape. It's a ring shape because it's a planetary nebula. So it's been formed when a star like the sun has run out of fuel. It's not gone supernova. It's essentially just fizzled out, and it's pushed its outer layers into space, making this beautiful ring around a white dwarf that's left in the center, that's then illuminating the gas around it so that we can then see it. The Southern Ring Nebula is about 2,000 light years away or so, and I'm really intrigued to see what that's going to look like with James Webb. I think they're looking at it because, that's sort of the eventual fate of the sun as well, so it'll help understand sort of the life cycle of stars, and it'll probably just look spectacular. Then you've got WASP 96b, which I think everyone in this room is probably the most excited about. There's a lot of exoplanet people here. So WASP 96b is an exoplanet, so it's a planet around another star in the Milky Way. And it's a hot Jupiter, so it's sort of more massive than Jupiter, just a big giant planet, but it orbits its star really close in. It only takes 3 days to fully orbit its star, so that tells you how close it is, how hot this hot Jupiter is. It's about, 1,150 light years away. And with this, we're not going to get an image, we're going to get a spectrum, where you take the light that's passed from the star through the planet's atmosphere and then to the telescope, and then you split it into its component wavelengths, and then you can actually see, the sort of signatures, the fingerprints of what's in that atmosphere. So if there's methane, or if there is ozone, or if there's, I don't know, carbon dioxide, something like that, it's going to show up in the spectrum of this planet. So it'll show up as like a peak to say, okay, here is methane, here is ozone, that kind of thing. And people are really excited for that, because obviously with WASP 96b, nice bright target, big planet, big thick atmosphere, you get a lot of light that passes through it. But in the future, obviously people are hoping to do this with Earth-like planets as well, and that's where people are going to get excited to see if we can maybe see, with super Earths or Earth-like planets, what's in the atmosphere. Is it similar to what's in Earth's atmosphere, things like this. And that's going to be the only spectrum I think we see today, rather than an image. And I know a lot of the public are going to be like, oh, it's just a line, but all of us here are going to be like, oh, look at it, look at the resolution, it's going to be like really really crisp and clear. I think as well, you're going to be able to see all the detail. And so if you see the line later and you think, you know that the rest of us are very, very, very excited about it. And then most relevant to my research is the last thing of that list. There was 5. The fifth one, the SMA CS0723, is the one we had last night from President Biden. The fourth one, though, is the last one, and that is Stefan's Quintet, which is this essentially really compact group of 5 galaxies clustered very close together in the universe, so close that 4 of them are actually interacting with each other as well. And it's about 290 million light years away, I've got written here as well. So it's a spectacular sight with Hubble, but with James Webb, again with the infrared, we'll be able to see through any of the dust in the systems that's hiding a lot of the star formation, so perhaps maybe star formation triggered by the interaction as well, and maybe we'll be able to see again the sort of dust emission around those galaxies. MIRI, if they've taken it with MIRI, I'm not sure. We just have to wait and find out what we've actually got. So yeah, we got about 6 minutes left to go. There's a big room where we're all going to stream and watch it from, so I'm really excited to not just capture my reaction, but sort of the room's reaction as well. I think it's going to be really, really cool when that finally happens. And as I said, if you weren't here at the beginning, because the stream is an hour long, and I think they're sort of releasing one image, then talking about it, and then another image, and then talking about it, I'm just going to record my reactions and then edit them down later and pop them up on YouTube, hopefully later tonight, rather than doing a full hour long session, because I know you'll want to watch the NASA live stream as well, all of you. So I guess I'll see you on the other side of this. We've just had that one image to tease us so far, and then obviously we've also got all of the early release data science programs as well. So everyone who got lucky to say we're going to do your science first, all that data is also going to be released. We're not sure if it's today. We think it's just what we call a JPEG today, so like normal image format today, and then astronomers sort of data format with all the sort of pixel information and everything might be Thursday, as far as I know. So I think Thursday is going to be good. People are going to be trying to get the real data and just like hack on it essentially and see what they can find, which will be really, really fun. And yeah, just I can't believe we're finally here, to be quite honest. I mean, I only joined the sort of field in 2013 at the start of my PhD, and even then everything was all about web and that it was coming in 2015, and then 2017, and then 2019, and now I'm finally here in 2022. I can't imagine how people who've worked on this for decades, for their entire lives, are feeling right now. So see you on the other side, and I'll have some reaction videos for you tonight, and then hopefully Thursday's regular video slot is going to be an explainer of what we can see in each of those images, and maybe pick out some of the stuff from the early release science programs as well. So thanks everyone for joining me, for saying hi, for all of those on the live stream as well, and yeah, see you on the other side. Oh, one last thing I do want to say is obviously the thing that people are going to forget to say today is a massive, massive kudos to the whole team, NASA and the European Space Agency and the Canadian Space Agency, for all of their efforts, because they are absolute heroes. All right, enjoy guys, see ya.